In this lesson, I'm going to talk about another way of calculating the enthalpy of reaction. So the second way of calculating enthalpy of reaction is by using bond enthalpies. Now, a bond enthalpy is the enthalpy change for the breaking of a particular bond in 1 mole of a gaseous substance. So when we're talking about bond enthalpies, it's the change in energy that occurs when a particular bond is broken. So we're going to be using bond enthalpies to calculate enthalpies of reaction. And so what we need to keep in mind is that when breaking a bond, that requires energy. Therefore, breaking bonds is always going to be an endothermic process, while making bonds is going to be exothermic. And so what we need to do is we need to provide enough energy to break the bonds that are not present in the products, and then we're going to form the bonds that are not present in the reactants. So basically what you'll do is you'll look at your reactants, look at all of the bonds in your reactants, look at all the bonds in your products, and then see what is not present in your products and what is not present in your reactants. And so let's look at an example to truly understand this. So here's your formula. Notice it's bond enthalpies that are broken, which is your reactants, minus your bond enthalpies that are formed, because your bond enthalpies will always be positive values, and therefore in order to represent that, it's our reactants that go first, and then we take the negative of our products, the bond enthalpies of our products. And keep in mind that that symbol right there represents the sum, so we're going to sum all the bond enthalpies that are broken and subtract from that the bond enthalpies that are formed. So if we look at this reaction right there, this diagram here helps us to really understand what's going on. So if we start with our reactants, we've got methane and we've got chlorine gas. And notice in our products, we have CH3Cl and then we have HCl. So if you look at all of the bonds, look at this diagram right here, look at all of the bonds that exist for your reactants, and then look at all of the bonds for your products. Notice that you are breaking one of the carbon-hydrogen bonds and replacing it with a carbon-chlorine bond. The other bond that's being broken is your chlorine-chlorine bond, and what's being formed is a hydrogen-chlorine bond. So although it looks like you have completely different products, in fact, you're only breaking 2 bonds and you're forming only 2 new bonds. And so what we're going to do is, here are our bond enthalpies. We'll use those in order to calculate the heat of reaction. So I'm going to take the bond enthalpy of carbon and hydrogen, and so I represent that bond enthalpy with D, so it's the bond enthalpy D of carbon and hydrogen, and I'm going to add to that the bond enthalpy of chlorine in chlorine, and I'm going to subtract from that the bond enthalpy of carbon and chlorine, because that bond is being formed, and I'm going to add to that the bond enthalpy of hydrogen and chlorine, because that's being formed. So notice, guys, the hardest part here is figuring out which bonds are being broken and which ones are being formed. Once you figure that out, all you have to do is sum all of the enthalpies that are broken and subtract from that the sum of all the bonds that are formed. So just as a quick review, looking at that diagram really helps, because it helps show you that a carbon-hydrogen bond is being broken, a chlorine-chlorine bond is being broken, and then a carbon-chlorine bond is being formed, and a hydrogen-chlorine bond is being formed as well. So to do this mathematically, I'm going to take the bond enthalpy of carbon and hydrogen, which is 413, and I'm going to add to that the bond enthalpy of chlorine and chlorine, which is 242. And then I'm going to subtract from that the bond enthalpy of carbon and chlorine, which is 328, and add to that the bond enthalpy of hydrogen and chlorine, which is 431. Okay? And so you take the sum of the bond enthalpies that are broken, subtract from that the sum of the bond enthalpies that are formed, and you have your enthalpy change for that reaction, which is negative 104 kilojoules. So my recommendation for doing all the practice problems, making sure that you clearly label what bonds are going to be broken, meaning what bonds do not exist in your products, and then looking and seeing what bonds are formed. A really nice way of doing that is actually drawing out the Lewis structure, just like how this is drawn out here, even though this is ball and stick models. You can also just do it with Lewis structures.